Welcome to Developing Graphics Frameworks with Python and OpenGL, Part 12, Creating Animated Programs. In this video, we're going to use the uniform class developed in the previous video to render an image containing two triangles with the same shape, but in two different locations and with two different colors. And so the code we need to accomplish this, now that we know about uniform variables, will include the following basic structure. First, we're going to be rendering two triangles which are effectively the same shape, but we'll only need to use a single vertex buffer, because we can just apply a transformation to redraw that same data in two different locations. And this is very useful. We don't want to have to upload a brand new buffer for every single location of a triangle. We'll also only need to use one GPU program, but that GPU program is going to contain two uniform variables. One will be used by the vertex shader to translate the triangles, and the other will be used by the fragment shader to change the color of the triangles. Right? And in addition to the two uniform variables, those values will be set by two uniform objects, which we're going to create. All right, so we're going to start right off by just writing some code to test out that uniform class. So I'm going to go ahead and start up Sublime Text. And let's see, this is video number 12. So I'll create a new test file. Again, in my base folder, a new file. I'll save it called test-12.py. All right. First, we need to import all the wonderful classes we've been using so far. So from core.base, we will import base. From core.opengl-utils, we will import opengl-utils. From core.attribute, we will import the attribute class. From core.uniform, we will import the uniform class. And finally, we need the OpenGL functions. From opengl.gl, import asterisk. All right. Now we're going to render multiple triangles in a very efficient way, just using one vertex buffer, but changing them around with uniforms. As always, I call the class test. We extend the base class, and we have two functions to define. First, initialize. We'll print a message. We're initializing the program. And then we'll go ahead and write our shaders. And this is the first new feature. First, vertex shader code. Multi-line string, so using 3 quotation marks. I'm going to need my in variable, where I define the position. But now, I would like to use a uniform vec3 variable called translation. And this will store the amount that I want to translate the x, y, and z vectors by. And its value will be set by the GL uniform command later. Right, for void main, first thing I'm going to do is actually I'm going to take the position and the translation and add it together. And one of the things that I really like about OpenGL is that the different arithmetic operators are overloaded, so you can use things like addition and multiplication on vectors. They're effectively basic data types. Next, in every vertex shader, we need to set the value of GL position. That's going to be a vec4. And we'll just read off the components of position. pos.x, pos.y, pos.z, and the magic number 1.0 at the end. All right, so we combine the translation with a position, put that in a new vector, and use that to create the final position in the vertex shader. Okay. Close the triple quotes, And next we're going to write the fragment shader code. So fs code equals triple quotation marks. All right, here, again, we're going to use the uniform. The syntax is the same. Just we use a type qualifier, uniform. Vec3, I'll call this base color. And void main. As always, we need to set GL frag color. That's going to be a vec4. And I just need to read off the components of base color for the R, G, and B, red, green, and blue. And 1.0 for the alpha. And for the, we want the fully opaque color. If we put in a 0 here, it would be completely transparent, we wouldn't see a thing. All right, so that's the only line of code we really need for the fragment shader. We'll go ahead and close off that code. Next step is to go ahead and initialize the program. And for that, we have the very convenient OpenGLUtils class. So let's go ahead and say self.programRef is equal to OpenGLUtils dot initialize program VS code, FS code. All right. That'll compile the program. We'll store the reference so we can use that later on. We're going to start setting up attributes next, but before we do that, we need to set up a vertex array object to manage that data. All right, so vertex array object, and again, we only really need one of those. Since we only need one, we can just set it and let it be. glgen vertex arrays, we only need one, and then glbind vertex array VAO ref. All right, that's going to store all the data for us. Next, let's set up the attributes. In this case, we really only have one. We only really need to define the position of the vertices of a triangle, kind of like in a base location. So let's say, let's call this position data. Again, just the triangle, so 0.0 is the first vertex, 0.2, 0.0. Next vertex will be 0.2, negative 0.2, 0.0. Last vertex will be negative 0.2, negative 0.2, 0.0. And so this will roughly define an equilateral triangle which is centered at the origin. All right, let's create an attribute with this data. We'll call it position attribute. And it's going to be a new attribute object. The data type is vec3, and we're giving it position data. And then, since we have our program reference, we can set up the variable association. Position attribute dot associate variable. Again, we always need to give this the program reference and the name of the variable, which is position. Excellent. All right. Now we also need the vertex count. So I'm going to also create a self dot vertex count equal the length of position data, which is 3. Excellent. Now we need to set up the uniform objects as well. And these don't get bound to a VAO or anything. We have to manage these separately, so we will have to store them in self variables and repeatedly upload the data before each draw call. All right, so next step is to set up uniforms. All right, so first I will do self.translation1. That'll be a new uniform. I'm just gonna, since it's a lot shorter than an array, I can just go ahead and just code that in right here. The first one I'll want to move to the left. So I'll translate it by negative 0.5, 0.0, 0.0. All right, that'll be my first uniform variable. To figure out where it's going to go later, we'll run the locate variable function, and for that to work, we need the program reference and the name of the variable it's corresponding to, and that was a vector called translation. All right. We also want to set up another translation. We're going to create kind of two copies of this data in different locations. So I'm actually going to copy these two lines of code. The second one I will rename translation 2. So I'm changing those numbers right here. And I'll change that value to positive 0.5. All right. So far, so good. We have two uniforms representing translation. Let's now set up some uniforms to change the color. First one, let's call that base color 1. That'll be a uniform, again, vec3. And for the first one, maybe we'll make it red. So that corresponds to the vector 1.0, 0.0, 0.0. And we have to locate this as well. And so again, we'll run the locate variable function in self.programRef. And we're looking to put this in a variable named base color. All right. And again, the second triangle, maybe we'll color this one differently. So I'll make yet another uniform. Basically need a full set of uniforms for each new instance that we're going to draw of this triangle data. So copy paste those two lines of code. Let's change them both to base color 2. And let's change this other color to blue. All right, so here we have it. We've got a total of 4 uniforms, and we're going to apply those in the update function. We're going to use the same program. We're going to draw the same buffer data, but applying these uniforms before each draw call. Let's go ahead and write that code right now as well. So we're going to create the update function. And so it needs to indent correctly. This is called update self. And first thing we're going to need to do is set the program, gluse program, self.programRef. Then we'll draw the first triangle. Got to upload some variables, some values to the uniform variables. And so we'll do translation 1. Say, go ahead, upload your data. It's not a lot of data, so it's not too hard to upload this every frame. Self.baseColor1, upload data. And then we'll do GL draw arrays. And in this case, we'll use, these are triangles, like it filled in. Let's use GL triangles, 0, self.vertexCount. Then I'm just going to copy these 3 lines of code and do it again to draw the second triangle. So I'm changing a few things. First in the comment, let's change that to say draw second triangle. And I'm changing the uniform variable here. So I'm using translation 2 and base color 2. And then I just run draw arrays again. Remember, draw arrays runs the shader program. But since there's now new values in these variables, it's going to look a little bit different. Okay. Now we're ready to, we're almost ready. We need to first, of course, create an instance of class and run it. Right, if everything's spelled correctly, and hopefully we'll see 2 triangles, a red one on the left and a blue one on the right. Let's go ahead and go to Tools, Build, and see what we see. All right, what does this not like? let's see, in upload data, GL uniform 3. Oh, so one of the tricky things about the uniform function, it's so tricky that I forgot about it. Let's head back to the uniform class. One thing you might have remembered from this slide is when you have more than one piece of data, you actually need to send in the arguments separately. So we can't actually pass it a vector, we have to separate out those components. So to fix this, we need to return to the uniform class. Let's go down to the upload data function in the uniform class, and there's 3 lines of code we're going to need to fix. Right, so underneath data type vector2, since the data in this case is a vector, we're just going to go ahead and type in the different elements of this vector. So self.data0, self.data1, maybe I'll put this on the next line. Okay. So we need to put those in separately. Can I fit on one line? No, not really well. All right, so we're sending in the data separately here. We need to do the same thing for vec3. So self.data0, self.data1, self.data2. And then again for vec4, self.data0, self.data1, self.data2, self.data3. All right, so that should address that issue, right? We were passing the wrong kind of data. We needed to actually pass 3 parameters there. All right, let's head back to our test class. Right. Let's go ahead and save, and let's try building this again. Hey, look at that. So indeed, we have 2 different triangles built from the same vertex buffer data. Right? You see that they have the same overall shape, but one has been translated and a red color applied, and the other has been translated and a blue color applied. Very cool. So that is how you use the uniform class to reduce kind of the number of vertex buffers you would need to use. Again, since this is really the same object just drawn twice, you wouldn't want to have to create 2 separate buffers just because they're in different positions. That would feel a little bit redundant. All right, now from this base program, we can do something fun. We can actually animate the program a little bit. So what I'd like to do is maybe take one of these triangles and just move it across the screen. In order to do that, I would need to take the data from a uniform and just update that data over time. So I'm going to go ahead and do that now. And I'm going to go ahead and close this window, go back to the test program, and we're going to make it a little bit more exciting. All right, so the changes that we're going to make. Let's see, what we're going to do is maybe create some kind of a time variable, right? And do we need time? It depends on how we actually want to implement the changes. Right, so let's do the changes one by one. First, let's maybe change the position of the red triangle. And so what I'd like to do for the red triangle, that's the one on the left, I'd like to take, maybe we'll say the y component. That's the component at position 1. I'd like to change this value. Maybe I'll add a small value to it every time we run through the update loop. Right, so right before we upload data, I could take the translation uniform, take its data, and I'll just add something to it. Maybe we'll add 0.01. And then I'll go ahead and save that. And so with a slight change in data, it'll appear to move down the screen slowly. Remember, this is going 60 frames per second, so actually maybe this is not quite so slow. We'll see that in a second. But before we do that, there's actually one more thing we need to do. We're going to need to clear the screen. We need to clear the color buffer before we go about that. Right? If we don't, then as you re-render the scene, the pixels really have just been rendered 60 times a second, but it keeps drawing on top of the old color buffer. We haven't actually refreshed or cleared the color buffer at all yet. Honestly, we haven't needed to, so we saved that fun until it was necessary. Right? In order to clear the color buffer, here are the functions that we're going to need. First, we can specify what we want the background color to be, and that's done with the function Glclear color. So we specify the amount of red, green, blue, and alpha. If we don't specify these values, the default clear color is black, right, which is the default color that we actually saw on the screen already. Right, that sets the clear color. To actually perform the clearing operation, there's a function called Glclear, and this can be used to clear all sorts of buffers. Right? Remember the frame buffer, which stores all our data corresponding to the image. The frame buffer could include a color buffer, a depth buffer, a stencil buffer, and so you can specify which of these you want to clear. There might be some situations in which you want to clear colors but not depth, or depth but not colors. So in order to reset those to these default values, what you need to do is some combination of OpenGL constants for this variable called mask. Right now we're only working with colors, so we'll just use the constant glColor buffer bit, separated by underscores. When we start working with depth, and when we're doing true 3 dimensions, then we'll also need to clear the depth buffer. But for now, that doesn't matter so much. So again, to avoid the appearance of smearing in our application, we're going to add these functions into our code. So going back to Sublime Text, what I'd like to do is, after we use the program, we'll go ahead and clear the screen. And we do that with glClear, glClear, or color buffer bit. All right. And just to show you how it works, we could set a different clearing color. So for instance, if I, instead of dark black, I wanted to say maybe use gray, I could set that up here somewhere. Right? There's no reason to keep resetting the same, or to keep setting the clear color in update. Might as well just set it once at the beginning of the program. Right? And traditionally, I've been doing that up here. Right? So in the initialize, usually I have a section for render settings, a glClear color. Right? Maybe I'll make this 0.6, 0.6, 0.8, 1.0. I think that'll be kind of a lightish blue-gray. Well, let's find out. Okay, again, we're changing the background color of the window with these new functions we just learned about, glClear color and glClear. We're updating the data before we're uploading the data. Let's go ahead and save and give this a run and see what happens. Hopefully good things. Hey, and there it goes. Did you see that? That red triangle just went right up the screen. That's pretty cool. Let's run that one more time. In case you missed it the first time, don't blink. Right, and there goes the red triangle right up the screen. And that's how we can create kind of a basic animation. It's a lot of fun. In that example, we changed the position of the triangle relative to its previous position. Right, so we didn't really have a formula to calculate the position per se, but I'm going to show you how to do that next as well. Right, no matter what the starting point of the triangle would have been, this code would have moved it up. What if instead you want to change something kind of as a function of time? I'm going to show you how to do that next. So with that other triangle, I'd like it to do something as well. Maybe I'd like that second triangle to kind of fade in and out from maybe a blue color to a black color and then back to blue. And so to do that, I'm going to add a little bit more code to this example. First, I'm going to go to the initialize function, and I'll say self.time equals 0. And so we're going to start keeping track of elapsed time in our program. And we can use time to do some pretty neat things. Right, within update, we're going to go ahead and we're going to update time. Right, so maybe right after we clear the screen, self.time plus equals. There's a better way to do this with a Pygame clock object, which we might cover in another video. But for right now, I'm going to go ahead and just assume that the program is running at 60 frames per second and add a 60th of a second to this program, or to the time variable. All right, so self.time will always tell us how much time has elapsed since the program started. Now I'm going to use self.time to actually calculate a new value for the color of the second rectangle, just for something fun and different. To do this, I'm going to use a little bit of trigonometry. Right, in particular, I'd like it to oscillate back and forth. I'd like it to go from blue to black to blue and back. Right, and anything which moves in kind of like a wave pattern, you can use a sine function to calculate those values. Right, so from math, I'm going to go ahead and import sine. Oops, not settings. I'd like to import the sine function. And we'll see how this is used in just a moment. Right, so I added that up in the import section of our example class. Now let's go down here to the update function, which runs 60 times per second. When drawing the second triangle, I'd like to try to do self dot base color 2, because we're in the second triangle. And I'm changing the value of the blue component of the color. That's the element in index 2 of the list. And I'm going to set this equal to sine of that time value. And, well, sine technically goes between -1 and 1, which isn't quite right, because the color value should go from 0 to 1. Since this goes from -1 to 1, what I can do is a little bit of math to kind of change the range. If I add 1 to this value, then instead of going from -1 to 1, I've shifted that range up, the values from 0 to 2. Still, this isn't quite right, because color values should go from 0 to 1, and 0 to 2 is twice as large a range as we need. So I'll also divide that entire expression by 2 to make it half as big. And so I'll put all of that in a set of parentheses and then divide by 2. And that'll give me a good range of colors. That'll give me the values 0 to 1. Right, so we don't really need to know a lot about the sine function. We just need to know, well, basically what it looks like. It oscillates. We need to know its range of values in case we need to manipulate that using some math. Also, it's useful to know that it goes through a complete cycle every 2 pi units. That's a little over 6. So this means over a little over 6 seconds, it'll cycle through the complete color changes. All right, enough talking. I'm going to go ahead and save this program and build it one last time. And hopefully we'll see, right, that red triangle went up, but hopefully you're looking at the second triangle, which is bright blue, and then it goes down to the color black, and then it fades back into the color blue. And again, this is happening about every 6 seconds. Right, going from blue to black and back. Right? And that's how we'll do some basic animations. That's really exciting. Right, there's lots more fun things we could do. There's lots more ways we could animate things. But really, I'd like to soon move on to interactive programs. Right, so in the next video, we're going to learn how to use some of the built-in Pygame functions to monitor user input and work with keyboard input. In the video after that one, we'll learn how to use keyboard input to kind of move things around the screen. That'll be pretty exciting. But that's it for this video. Thanks for watching.